Hello. I'm going to go through a harder version of the area between problems and review over those calculator skills that are super helpful for these types of problems. So if you look at this particular example we didn't get to in class, you have y equals x to the third, and then you have a function that's a function of y instead of a function of x. So you're going to have to solve one of those for the other variable in order to do this. Now, in this particular case, the plain old top minus bottom actually doesn't work. So I'm going to show you basically what I mean. So over here, we're going to do this as a dx problem. And then over here, we're going to do it as a dy problem. Okay, so first thing is a good idea to get a sketch going. So I'll just do a quick sketch of what this graph looks like. So y equals x to the third basically looks like this. And then x equals y squared minus 4. So it's a parabola facing sideways, opening to the right. And then we're starting at a -4. So we're over here. And then we have a parabola going this direction. Okay, so if I was going to do it with respect to x, I have the y equals x to the third, which is good. And then these two guys, I would have to split up into two functions. So I would add 4 and then take the square root, but you do have to do plus or minus. So this obviously top part would be the positive square root of x plus 4. And then the bottom part would be the negative square root of x plus 4. And we're going to do the area between those two curves. So what we're looking at is this area, because we have an intersection here and we have an intersection here. So the reason why the top minus bottom doesn't work is you have to have, in any x value you pick, the same function on top and the same function on the bottom. So if I pick an x here, obviously the parabola is above the cubic. Here, parabola is above the cubic, parabola is above the cubic, until you get to here, and then it's just bounded by the parabola, and in the cubic doesn't matter. So you would have to split this up. So it's possible to do it this way, but it is not as easy as just saying, okay, x to the third minus the square root of x plus 4. It's not that easy for this particular question. So you want to look for, of course, the intersection points. So you would find those. I'm not going to go through that for this particular thing, but let's say that is the B, and here this intersection, that is the A. Okay, from A to B, the parabola is above the cubic, or the positive square root piece is above the cubic. So we can start it out with one of our integrals from A to B. So you would find those. I won't do that in this particular piece. And then we would do the positive square root of x plus 4 minus the cubic with respect to x. So that would basically be this part of the graph, right? So that represents that the blue crossed section there. The other piece here, the top function is the square root, positive square root. The bottom function is the negative square root. So we would have to do a different interval. So I would add on another integration problem. And we know that this point here is that -4. So I'm going to go from -4 to A. And then I would do the positive square root minus parentheses. And you really should always put parentheses just to get in a habit. Positive square root minus the negative square root of x plus 4. Okay, so you can split it up and do it that way. You just have to be super careful, obviously, looking for those intersections and then making sure that the top minus bottom is appropriate for that part of the graph. Okay, so that is how you would do it with dx. But this particular problem is probably easier with the dy. And I'll show you what I mean. So I am again going to draw a real quick sketch of it. Like that, and then we're at -4. We do our parabola sideways. Okay, but if we're going to do dy, you do need to have them in terms of y. So I'm going to take this guy and I'm going to rewrite him as an x equals problem. So you cube root both sides. So now we're going to do the cubed root of y, and then the parabola piece is just the x equals y squared minus 4. Now remember, when you're doing a dy problem, you want to do right minus left. And this guy is going to work. So what you want to double check for right minus left is for any y value. So here, pick this y value. Okay, the cubic guy is to the right of the parabola. And that's true, any y value that I pick. Because remember, maybe I'll draw lines this way this time. But remember, we're looking at this shaded region here. And for any point on the y-axis, the cubic is to the right of the parabola. So I can just do a right minus left with respect to y. Okay, so a couple of things you want to think about. We still need to figure out the intersections. And those are going to be with respect to y. So I'm going to be looking this direction for my a and my b. And those would be my bounds for the integration. And then I would just do the cube root of y minus the y squared minus 4. But I'm going to go through one more time with you how you do determine those intersection points with your calculator. And we're going to do it in a slightly easier way, I think. All right, so obviously you would set those equal to each other, or you can graph this and set them equal to each other, but your calculator doesn't graph x equal equations. So that's a problem. Okay, so we're going to talk about how to get around that. So let's just start out. We know that algebraically what we would do is just set those equal to each other and then solve for y. Well, this would be a hard one to do algebraically. So I am going to subtract this guy, basically setting it equal to 0. And then when I find the zeros for this particular graph, those are going to be my intersection points. Okay, you'll also notice that this represents the right minus left. Okay, so let's look at our calculator. So we're going to use this equation and set it equal to 0. Now you're not going to like this, but that equation, you can't put in the y's. Everything on your calculator, the calculator's dumb, everything on your calculator is y equals. So the thing is you got to keep in mind is these could be w's, they could be p's, they could be smiley faces. It doesn't matter what the variable is. And so when you're going to plug it into your calculator, you're still going to have to use an x. And I know you're not going to like that, but you got to imagine it's a w or a t. Okay, it's a value that your calculator is going to help you find. Okay, so I'm going to use an x because the calculator doesn't like to play with anything but an x. All right, and I'm going to graph it. So you get this weird looking, sort of parabola looking thing. And we're going to look for the zeros. And those zeros are going to be the intersections from this graph. Okay, so zeros, you go here, you pick option 2, you go to the left, bound, enter, go to the right, enter, and then enter. Okay, so I have an intersection, and remember, this is an x equation right now that I plugged into my calculator. So the x value is what I want to store. So reminding you how to store stuff, we're going to go to the main screen, store it right away. So go to the main screen. You just want to make sure that that value is still there. So you click X, hit enter, make sure that's the value you want, it is, and then we're going to store. So STO is the store button, and then we're going to store it, let's just store that one in, I think I made that B. So alpha, and then here's the B, and then enter. Okay, so now the 2.3, or the positive 2.306795536 is stored as B. Okay, you do want to note that on the AP exam if you are going to use a letter. So that was 2.3067954. Okay, so make note of that. Now we're going to go back to our calculator and look at the other zero. So we found that one, so now we're going to find the other zero. I'm going to go over there. So we're going to go to the left of it, hit enter, go to the right, hit enter, and then enter one more time. Okay, so here's my other bound, negative 1.67, blah, 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 blah. Again, right away, you want to go to the main screen. And now we're going to double check that that's what's in the X. Okay, which it is. So this X got replaced with that X on our second zero. And then we're going to store. Now we're going to put that in A. And that's not what I meant to do. So alpha, and then here's the A, and then enter. Okay, so now I have the other bound in the A value. So now I'm going to let A equal, and that was negative 1.676887. All right, now those values are representing these Y's, even though we wrote literally the X in there. Okay, again, the calculator doesn't do anything but X's. So it doesn't matter what letter you have here, you have to put the X in there. But it is, in this case, representing the Y. Okay, at that point, we are going to set up our integral. We're going to go from the negative to the positive. You always want to do the lower number at the bottom. So this would be A to B. And then here is going to be the right minus left. So cubed root of Y, and then minus, and I could distribute that, right? So Y squared, and then plus 4, and this would be dy. Okay, on your calculator. So remember your integral is function 9. And then we're going to go from A, so alpha A, go up to B, alpha B, and then over. And then this is the nice part. You could write that whole function out again. But remember, when we're using the zeros to figure out the intersections, that's exactly what we wrote in here as our y1. So this is a little bit of a shortcut as well. So if you, instead of using intersections, you use the zeros by just subtracting the functions. That makes your ending part here a little bit easier. Because what I can do now, let me go over, what I can put here is just y1. So I go alpha trace to bring up the y1. And then remember, we did this on the calculator in terms of x. So that's going to be an x. Even though over here, this is all in y's. The letter doesn't matter. Could be t's, could be smiley faces, doesn't matter. But your calculator will only do x's. Okay, and then we're going to hit enter. So we get 11.063. Generally, we go to thousandths. So 11.063 is my area between the curves. Okay, good job. You could double check that this one matches, but I'm sure it does. I'll see you soon. Bye.